Hello students, and welcome back from fall break. Today we are going to begin EQ5 sequences. This will cover how do you distinguish between arithmetic and geometric sequences, how do you write arithmetic and geometric sequences with an explicit formula and use them to model situations, and how do you write arithmetic and geometric sequences with a recursive formula and use them to model situations. Distance learners, what do you need today? You need a pencil and paper to do examples or dry erase board and marker. You need your notebook, and the first thing you need to do is start a word wall quarter 2 page. You should be writing all of your word wall words and definitions in your notebook, just like the students in class are doing. That is your responsibility. It is also your responsibility to take notes, just like the students in the classroom take. Here are our first 4 word wall words of quarter 2. Please pause your screen to copy these into your notebook. Those first 4 word wall words are arithmetic sequence, a sequence of numbers where each term after the first is found by adding a common difference. Geometric sequence, a sequence of numbers where each term after the first is found by multiplying by a common ratio. Common difference, the difference between each number in an arithmetic sequence. And common ratio, the ratio between 2 numbers in a geometric sequence. And we will learn about these words in our lesson today. The first thing we will be covering today are arithmetic, or the first thing we will be covering is arithmetic sequences and geometric sequences. I recommend taking your own notes on this page. I would title it Arithmetic Sequences, and then put a bullet point and copy this next portion. A list of numbers in which you add or subtract the same value every time to get the next term. Then write example and copy this example. Our example shows the sequence 1, 4, 7, 10, continuing. And we can see that each time we are going up 3. The term that we add or subtract, in this case add, is called the common difference. And I would make that another bullet point in your notes. So at this point, I would pause your screen to go ahead and write down your notes. So again, we are looking at arithmetic sequences. Arithmetic sequences add or subtract, and we call this a common difference. So we're going to look at a few examples. Feel free to copy any of these in your notebook or just to do these on your own, on a dry erase board, or on a sheet of paper. Determine if the sequence is arithmetic. If it is, find the common difference. Example 1, 3, 7, 11, 15. So if we take a look here, 3 plus 4 is 7, plus 4 is 11, plus 4 is 15. So I am increasing or adding by the same amount. So yes, this is arithmetic. And then what's my common difference? When we write a common difference, we're going to write lowercase d equals, and in this case it's a positive 4 because we are adding 4 each time. In example 2, we have negative 2, 1, 2, 4. So to get from negative 2 to 1, I would have to add 3. Then to get from 1 to 2, I would add 1. And to get from 2 to 4, I would add 2. So this is not arithmetic. We are not adding or subtracting the same term. Example 3. 5, 1, negative 3, negative 7. So I ask myself, how do I get from 5 to 1? 5 minus 4 is 1. 1 minus 4 is negative 3. Negative 3 minus 4 is negative 7. So I'm subtracting 4 each time. So yes, this is arithmetic, and my common difference is negative 4. Positive tells me I'm adding. Negative tells me I am subtracting. All right, the second portion of your notes is geometric sequences. So go ahead and title this second portion, Geometric Sequences. And then again, I would put a bullet point and copy this down. A list of numbers in which you multiply or divide by the same value every time to get the next term. For your example, you're going to copy down this sequence, 2, 4, 8, 16. And you can see that each time it says times 2. 2 times 2 is 4, times 2 is 8, times 2 is 16. Next bullet point, the term you multiply is called the common ratio. And then you're going to add one more bullet point. If it's division, you write it as a fraction, which we'll go over in just a moment. So again, your title is Geometric Sequences. Then you're going to be writing down this bullet point here, an example, another bullet point, and another bullet point. Go ahead and pause your screen to copy down your notes. All right, so now that we're back, first we looked at arithmetic sequences, which were adding or subtracting. Now we're looking at geometric sequences, and with geometric, we're either multiplying or dividing, okay? But we're always going to write it as multiplication. So when it's dividing, we need to write the multiplication form of that division, which we'll get to in just a moment. So if we look at example 1, we have 3, 9, 27, 81. So let's think in terms of multiplication and division. Normally, not always, but normally, multiplication is going to make you larger, whereas division will make you smaller. So to go from 3 to 9, I'm probably multiplying. So what am I multiplying by? 3 times 3 is 9, times 3 is 27, times 3 is 81. So this is a geometric sequence because I'm multiplying by the same term, 3. And I call this my my common ratio. R equals 3. R equals 3 tells me I'm multiplying by 3. Now let's look at example 2. We have 16, negative 8, 4, negative 2. So again, think about multiplication and division. Normally, multiplication makes something larger, division makes something smaller. So I am getting smaller. So what could I divide 16 by to get to negative 8? Well, if we just think in terms of numbers and don't think about positives or negatives, 16 divided by what would give me 8? That would be divided by 2. But I went from positive to negative. So in order to do that, I would have to be dividing by a negative 2. So then negative 8 divided by negative 2 would give me a positive 4. So negative divided by negative makes a positive. Positive 4 divided by negative 2 would give me negative 2. Okay? Normally, whenever you see it going positive, negative, you're multiplying or dividing, depending on which one it is, by a negative number. Okay? So here's where we have to go back. Okay? Yes, this is geometric, but I can't say R equals negative 2. If I say R equals negative 2, that tells me I am multiplying by negative 2, and I'm not multiplying here, I'm dividing. So then what we have to do is write the reciprocal, okay? The reciprocal. So the reciprocal means to flip the number. So if we think about negative 2, so I'm going to write it up here. As a fraction, negative 2 is negative 2 over 1. So then the reciprocal of that, if I flip it, becomes negative 1 over 2. So my common ratio is negative 1/2. okay, which tells me I'm dividing by 2. If you think about a fraction, the denominator is the number you divide by. So this tells me I am dividing by -2. All right, then we have example 3. Our sequence is 4, 2, 0, -2. So I ask myself, am I multiplying or dividing here? I am getting smaller, so it'd have to be division. So 4 divided by what gives me 2? 4 divided by 2 gives me 2. But 2 divided by 2 would give me 1, not 0. So this is not geometric. It is arithmetic, but it is not geometric. Okay, so one more time, let's just review. You don't have to add this to your notes, but you can if you want to. Arithmetic sequences increase or decrease by the common difference, which we write as lowercase d. That lowercase d represents addition with a positive number or subtraction with a negative number, such as in this example. 11 minus 2 is 9, minus 2 is 7, minus 2 is 5. So my common difference is -2. 3 plus 6 is 9, plus 6 is 15, plus 6 is 21. So my common difference is +6, which tells me add 6. Versus geometric sequences, which increase or decrease by the common ratio, lowercase r. If we have a whole number, we're showing multiplication. And if we write a fraction, we're showing division. So 2 times what gives me -10? That would be -5. 125 divided by what would give me 25? That's going to be dividing by 5. And then again, we have to write the reciprocal. 5 over 1 becomes 1/5. This tells me my common ratio is that we are dividing by 5. Remember, division must be written as a fraction, always. So let's do some examples, okay? So what I would like you to do is, using your notes to help you and guide you, pause your screen and either in your notebook or on your dry erase board, answer questions 1 through 4. Okay, you're telling me 2 things for each one. Is this an arithmetic or geometric sequence? And then what's the common difference if it's arithmetic, or the common ratio if it's geometric? So we'll do number 1 together to give you an idea of what I want you to do here. So number 1, the sequence is 1, 4, 7, 10, 13. So I can see I'm increasing here, which means I'm probably adding or multiplying. So to get from 1 to 4, I could multiply by 4. 1 times 4 is 4. 4 times 4 is not 7. So I could also do plus 3. 1 plus 3 is 4. Plus 3 is 7. Plus 3 is 10. Plus 3 is 13. So I'm adding. Therefore, this is arithmetic. And then arithmetic sequences have a common difference. And in this case, it's +3 because I'm adding 3. Go ahead and pause your screen to answer the rest, and then unpause to see if you're correct. All right, and here are the answers. For number 2, we had a geometric sequence. We are multiplying by 2. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Continuing. So this is geometric, and my R, my common ratio, is 2. For number 3, 15 minus 3 is 12, minus 3 is 9, minus 3 is 6, minus 3 is 3. Therefore, this is arithmetic with a common difference of -3. D equals -3. For number 4, -3 times -3 would give me a +9. +9 times a -3 would give me -27. -27 times a -3 would give me a +81. Continuing. So this is geometric, and my ratio is -3. Remember, if you're unsure, you could always use your calculator to double check your answers. All right. Next example, write the first 5 terms of each sequence described and identify the sequence as arithmetic or geometric. For this one, we'll do example 1 together. and then you try example 2. So example 1, the first term of the sequence is 0, and the common difference is -6. Common difference tells me this is arithmetic. And then we're going to go ahead and complete the sequence. So -6 means I'm subtracting 6 each time. Again, if you need to use a calculator, you can. 0 minus 6 is -6. Minus 6 is -12. Minus 6 is -18. Minus 6 is -24. Okay, we're actually going to go ahead and do number 2 together as well. For the first term of the sequence is -18, and the common ratio is 1/3. So common ratio tells me geometric, and then remember that when you see a fraction, that means division. So this is divided by 3. So -18 divided by 3, and again, use a calculator if you need to. It's going to give me -6. -6 divided by 3 is going to give me -2. And from here, I'm going to get into fractions, okay? So if you're using your phone calculator, just your regular phone calculator, it's not going to benefit you here because it's going to give you decimals and you need fractions. So again, I'm going to plug. You need to download, if you can, the Desmos Test Mode calculator and use the scientific calculator. It will show it to you as a fraction. Otherwise, you need to purchase a TI-84. It's going to be much cheaper to download the free app, which can do the same thing. So if you do that, we're going to have -2, which is -2/1, divided by 3. Okay, divided by 3. So dividing by 3 is the same as multiplying by 1/3, which is why we switch it. So -2 times 1 is -2. 1 times 3 is 3. So I get -2/3. Now I've got -2/3 times 1/3. Because again, dividing by 3 is the same as multiplying by 1/3. So -2 times 1 is -2. 3 times 3 is 9. So I get -2/9. Again, if you have the Desmos Testmos calculator, you could just keep hitting divided by 3, divided by 3, divided by 3, and it's going to show you those fractions. Alright, so for your next question, you can create this table either on a dry erase board or a sheet of paper or with your notes. And for each example, you're going to fill in 3 things. Is it arithmetic or geometric? Does it have a common difference or ratio, and what is it? And what's the missing term? So again, just like we did before, we'll do number 1 together, and then I'll let you try 2, 3, and 4 on your own. Okay? So when you're looking at these, for some of you, you might find it difficult to say, how did I get from -1 to +4? So in that case, you might want to look further down the line at 14 to 19. So what could you do to 14 to get 19? I could add 5. -1 plus 5 is 4. Okay? So then that gives me my missing term. 4 plus 5 is 9, plus 5 is 14. So I'm adding. So this is arithmetic. Since it's arithmetic, I have a common difference, and that difference was +5. And I found my missing term was 9. Okay, go ahead and pause the screen to answer 2, 3, and 4, and then unpause to check your answers. All right, here we go with the answers. Number 2 is geometric. It is dividing by 2. Again, I would have started here, 28 to 14 to 7. I can see I'm decreasing, which means I'm either dividing or subtracting. If I subtract, it would be 28 minus 14 is 14, minus 7, that doesn't work. But 28 divided by 2 does give me 14. 14 divided by 2 does give me 7. So remember, we write divided by 2 by saying 2 is a whole number is 2 over 1. So then we flip that to the reciprocal, which means divided by 2 to r equals half, 1 over 2. And that missing term would be 56. 112 divided by 2 is 56. Number 3, to get from 25 to 10, I would subtract 15, which makes this arithmetic, and my common difference negative 15. 10 minus 15 gets me to negative 5. Number 4, negative 25 to 50 to negative 100, so I'm increasing and I'm multiplying. So this is geometric. I am doubling each time, so I'm multiplying by 2. But then if you notice, negative, positive, negative, positive, negative, which means I'm multiplying by a negative number, because a negative times a negative makes a positive, positive times negative makes negative, and so on. So my missing term was positive 200. Right. Here are 2 more questions for you to answer. So again, go ahead and pause your screen to answer these. All right, and we're back. Which statement is true about the following sequence? Negative 1, 0, 1, 2. Before I even look at the answers, I'm going to see what I can tell about this sequence. So here's what I can tell. I can tell I'm increasing by 1 each time, which tells me it's arithmetic and it has a common difference of positive 1. So now let's look at our answer choices. Okay, has a common ratio? No. Has a common difference of negative 1? No, it's not decreasing. Has a common difference of positive 1? Yes. Has a common ratio? No, that's for geometric. So my answer is C. For the second one, which statement is true about the following sequence? 3, 9, 27. For this one, I'm multiplying by 3, which is geometric. So I have a common ratio of 3. Okay, so first thing I'm going to do is get rid of anything that doesn't say ratio. So I can get rid of B, and I can get rid of C. And then I have has a common ratio of 3 or has a common ratio of 2. We've already discussed it's 3. So my answer is A. Dante and Kira were asked to write an example of an arithmetic sequence. Who followed directions? Consider the first 2 terms of the sequence. 3, 6, continuing. Dante says, this is how I wrote the sequence for the given terms. 3, 6, 9, 12, continuing. Kira says, this is the sequence I wrote. 3, 6, 12, 24. So you tell me, who followed directions? Think back to remember that this is supposed to be an arithmetic sequence. So if we break down our problem, it should be arithmetic. My first 2 terms were 3 and 6. So arithmetic, I'm increasing, which means I have to be adding. So 3 plus what gives me 6? I need to be adding 3 each time. Okay. If we look at Dante's sequence, he's doing just that. He's adding 3 each time. So Dante's going to be correct. Whereas Kira has multiplied by 2 each time. Okay. Here's a word problem for us. Rico owns a sporting goods store. He has agreed to donate $125 to the Centipede Valley High School baseball team for their equipment fund. In addition, he will donate $18 for every home run the Centipedes hit during the season. The sequence shown represents the possible dollar amounts that Rico could donate for the season. So it says that he's going to donate $125. So that's the first term in our sequence. We're starting out with 125. Then notice it says in addition, which we know addition usually means add. He's going to donate $18 for every single home run. So every time they get a home run, plus 18, plus 18, plus 18, which you can see is happening here. So then we have our questions. Number 1, is this arithmetic or geometric? Well, we just discussed that it says addition in addition, and the addition is $18 each time. So this is an arithmetic sequence. What is the common difference or common ratio? First of all, arithmetic sequences have a common difference, so D equals, and it tells me right here in the problem, 18. I'm adding $18 each time. The key to these word problems is just looking for that important information and matching it up to what we know about sequences. Okay, determine if the sequence negative 184, negative 207, negative 230, negative 253, continuing, is arithmetic or geometric. Then identify the next term in the sequence. So again, let's break it down. Let's look at our sequence, okay? Our sequence here is decreasing because the negative numbers are getting larger, so it's becoming more and more negative. So we know it's decreasing, okay? Usually when we're decreasing, it's going to be an arithmetic sequence. We could decrease with multiplication. If we're multiplying by negative, it's going to make something turn negative, but then that's usually going to go negative, positive, negative, positive. It's not going to stay one way. So we need to know how we're decreasing, basically. Okay, so we already know it's arithmetic, so we can get rid of C and we can get rid of D. Okay, so how do I get from negative 184 to negative 207? If we take out the negatives for a moment, just think about how would you get from 184 to 207? All right, so if I'm at 184, I need 16 more to get to 200. And then 7 more to get to 207. So 16 plus 7 is 23. But I'm not adding 23, I'm subtracting 23 because I'm becoming more and more negative. So again, this is arithmetic because I'm subtracting 23 each time, and you can see that that will continue to work. If you do in your calculator negative 207 minus 23, you're going to get negative 230. Minus 23, negative 253. Now, be very careful here, because a lot of you are going to jump and say the answer is A, but that's not what it asked us. It says identify the next term in the sequence. We know the next term is not negative 23. That's our common difference. But if we did negative 253 minus 23, I'm basically going to add these numbers, get same sign, add 6, 7, 2, and keep the sign. So my answer is B. It's arithmetic, and the next term is negative 276. All right, consider the sequence shown. 270, 90, 30, 10. Devin says that he can determine each term of this sequence by multiplying each term by 1/3, so the common ratio is 1/3. Chase says that he can determine each term in this sequence by dividing each term by 3, so the common ratio is 3. Who is correct? Explain your reasoning. Let's look at our sequence. Okay. They're talking about multiplying and dividing, so that tells us that this is a geometric sequence. And it's going down. It's getting smaller and smaller and smaller, so we're probably dividing it. So, you know, we can try it out. So, Chase says that we're dividing by 3. That's true, right? 270 divided by 3 is 90, divided by 3 is 30, divided by 10, or divided by 30 is 10, and so on. So we know we're dividing by 3. So that means we do have a common ratio. But how do we write that common ratio? Do we write r equals 3? Or do we write r equals 1/3? That's the question here. So if we think back to what I told you at the beginning, r equals 3 tells me I'm multiplying by 3. Instead, I have to write the reciprocal 1/3 to show divided by 3. Okay, my term is divided by 3. So while Chase is correct in saying we're dividing by 3, he's incorrect in his common ratio. However, Devin says he can determine each term of the sequence by multiplying by 1/3, which is correct. Okay, dividing by 3 is the same as multiplying by 1/3. Devin is correct. All right, last question today is going to be your exit ticket. So determine if the sequence 0.2, 1, 5, 25 is arithmetic or geometric. Then identify the next term in the sequence. So you have answer choices A, B, C, or D. And you're going to answer this in your Kidem assignment that's attached to this. Have a great day. Make sure you tune in on Tuesday. If this is just my Monday learners, make sure you tune in tomorrow for my Zoom Live to discuss all the new expectations for distance learners. And have a great day.